Hello and welcome to this presentation on language features in C#6. In this presentation, we'll be looking at Roslyn, briefly, Roslyn, the .NET compiler platform, and then we're going to be going through a bunch of C# language features by looking at code. So I only have a couple of slides in this episode. Most of our time will be spent in Visual Studio, so we can look at the new features of C#. We can't have a discussion on the C# language features without first talking about Roslyn, which is the .NET compiler platform, which is also new to Visual Studio 2015 and the C#6 language features. In fact, these language features in C#6 have been implemented, if you will, in the new Roslyn C# compiler. So at this point, there are two C# compilers. There's what I call the native compiler, which is built in C and C++. Anders Hallsberg likes to call that C++. And then the new C# compiler that's written in C# itself, the Roslyn C# compiler. The Visual Basic compiler also has been written in Visual Basic in this in the Roslyn compiler platform. So what is Roslyn, and what is the motivation behind having such a platform? Traditionally, compilers are a black box. Some source code goes in on one end, lots of magic happens in the middle, and then object files come out. Object files or assemblies come out the other end. As the compilers perform this magic, they build up this very deep understanding of the code that they are processing. But this knowledge is promptly thrown away and forgotten as soon as the output is produced. So the mission of the Roslyn project is to open up this black box and allow tools and end users to share this wealth of information compilers have about the code that they're processing. Now that may not make a whole lot of sense to you at this time, but I'll explain further what the uses of Roslyn would be. And of course, right away, the question comes up in some people's minds is, if the native C# compiler is written in C and C++, and the newer one, or the Roslyn compiler, is written in C#, what about performance? So of course, performance has been a key consideration of the team, the Roslyn team, or the C# compiler team. And right from the get-go, they've been ensuring that the performance of the C# compiler is no more than twice as slow, if you will, so 2 times slower. But in fact, what's happened is, over the years that they have been building Roslyn, in fact, Roslyn has been in the making probably since, I think, 2009, if I'm not mistaken. So it's been a long time that they've been working on this compiler platform. And as you can imagine, lots and lots of things have to be taken into consideration. Not only just moving things over from the native compilers to C#, but also, I guess, setting up C# and Visual Basic as languages on the platform, on the .NET platform, to be able to embrace some of the new capabilities that computer programming languages are embracing, such as functional programming. So over the years, the C# compiler, the Roslyn compiler, has been improving in performance, and today it's at about 1.2 times slower. So it's 0.2 times slower, if you will, than the native C# compiler. But that's not quite the right statement, because that's not how you're going to perceive it. The native compiler is what I would call like a brute force compiler. So it can churn through code really quickly and produce the output, in this case, the IL, intermediate language, that the C# compiler produces fairly rapidly, quickly. But what it cannot do is, it can't multi-thread that processing really well, because it was not made for that. In today's desktop computers, of course, multi-core is standard. In fact, you can't buy a computer that's a single-core machine anyways. The Roslyn compilers have been built from the ground up to be multi-thread safe. And the way this works is that there is they use modern and functional algorithms in their C# compiler. The data structures are immutable. In fact, the entire AST, or the abstract syntax tree, is completely immutable, and that gives you the ability to I guess parse the syntax tree across multiple threads without having to add any kind of synchronization mechanism or thread safety while you're processing this. And so imagine that the Roslyn compiler can go through a specific C# file using multiple threads in parallel, and literally it can parallelize the processing of this file by, let's say, putting every method on a separate thread or separate core and producing the IL for it in parallel without any conflict or without any issues, which is something the native compiler cannot do. So what they found, in fact, is that in larger projects, because the Roslyn compiler can process these files in parallel, if you have a 2-core machine or a 4-core machine, you could potentially get almost 4 times faster performance in terms of compile times. So these the Roslyn compiler scalability for large projects is tremendous, vastly better than the native compiler. So moving on now to the next part, which is the rich code analysis aspect. So while the compiler is processing the source files and this magic that's happening inside this black box that is now being exposed to us as APIs, there are a few steps that a compiler typically goes through while processing source code files. Is it builds a syntax tree, so there's a syntax tree API available to us. Then it builds the various symbol tables, and so now there's a symbol API available to us. Then it does what they call the binding and the flow analysis, and so there's a binding and flow analysis API. And eventually, or finally, it emits the output as object files or assemblies or whatever the case may be, or IL. And so there's an emit API. So all of these APIs are going to be available to us as developers, tool builders, IDE programmers and such, to make use of the rich information that Roslyn develops about the code that is just finished processing or is processing, and we can make use of it. There's also a full fidelity between the syntax tree and the source code. By that, what I mean is, if you have an instance of a syntax tree and you do a toString on it, you get a source code. The source code is exactly the syntax tree in the sense that if the source code, let's say, were to have extra spaces somewhere or extra lines or whatever the case may be, the syntax tree represents that source code exactly. So you can go back and forth between source code and syntax tree and not lose any fidelity. Therefore, you can now manipulate the syntax tree, rewrite code just by manipulating the syntax tree, and then output the source code to now represent exactly what you knew or wanted or had in the syntax tree. Might not make a lot of sense, but imagine when you're rewriting code, cleaning up code, reformatting code, and rewriting code, then the syntax tree comes in handy because you're essentially manipulating the tree and not source code. You're not dealing with strings or text files. You're dealing with a structure, an abstract syntax tree that allows you to add things, remove things, yet keep the C# code semantics intact. So typically, of course, the Visual Studio IDE makes a lot of use of this kind of capability, and we will start to see. We already have in 2015, in Visual Studio 2015, some really cool new features that make use of Roslyn. And then, of course, there'll be tool vendors such as Resharper. Resharper will get even sharper. Style Cop. I personally don't like Style Cop at all, or at least that the way we are forced to use it. But just Style Cop gets even smarter too, if there's such a thing. And then you could have your own, I guess, refactorings, if you will, within your project or within your team, where you could have these code formatters or analysis tools that you build can be extremely what they call code aware and live. And I'll give you an example of this. So FXCOP today has does the analysis of your code, but it does it after the fact, meaning you go through the process, you compile, and then you do the FXCOP analysis or code analysis. So it's after your code is compiled that FXCOP does the analysis, and it can then give you some issues or problems with your code with regards to any conformance that you may or may not be doing. The live analysis aspect is that it can start giving you problems or highlight problems to you as you're writing the code, so you don't have to wait for the compilation to take place and then the analysis to take place. You can do the analysis live. As you're writing code, these tools can start to tell you either you're doing something wrong, or they can help you improve your code as you write, or refactor as you're writing it. And that's the idea behind code aware and live analysis. And code awareness is actually something that comes about because Roslyn and the APIs that you have access to give you this deep understanding of the language itself. So you're not just parsing C# text files or source files as text anymore. You are parsing and manipulating C# code files with full understanding of the C# language through the Roslyn API. So it's you have to look at the API to understand what that means. To be honest, it's very different from just parsing text source files, right? You're dealing with the Roslyn compiler has full semantic understanding and symbolic understanding of the C# language, and essentially when you're manipulating things, or you're querying it for certain information, it's giving you back the answers in terms of, I guess, in terms of the language rather than in terms of like there's a space here, there's a tab there, sort of thing. Now, because the Roslyn code base itself has been open sourced, to go back to the FXCOP analysis aspect or live analysis thing, another change that you're going to start seeing is, for example, in FXCOP again, there's such a thing as cyclomatic complexity. It's a I guess analysis that can be done. I'm not sure what versions don't have it, but I know the Visual Studio Ultimate version has it, and it's sort of a step that you do in addition to your compilation step, and you can ask Roslyn to do your code analysis, and it also tells you the complexity or cyclomatic complexity. Now, the way FXCOP does it today is it's really looking at IL. It's not looking at the C# code. It's looking at the generated IL and literally counting the number of jumps in your method, and then can tell you whether this method has got a high cyclomatic complexity or not. It doesn't understand the language per se, so it can't really give you the insight from the perspective of the language. We can imagine in the future FXCOP starts to do this analysis, but this time using the code aware and live analysis capability, such that it's looking at the code rather than the generated IL. And so from the perspective of C#, that code may or may not be complex, and it can give you a little more insight into the cyclomatic complexity of your code as per the way you've written the code, rather than the number of jump statements that might be visible in the generated IL. So the Roslyn compiler source code has been open sourced, and so you can go to GitHub. Again, you can see the address here, and download the source, compile, build the compiler, and you can then add it on to your Visual Studio. Visual Studio they have a add-in or VisX file for 2013 as well, but 2015 just comes with the Roslyn compiler. So if you want to play with the Roslyn compiler in 2013, you can download the V6 file and install it, and then you can uninstall it if you want to compile your applications with the native compiler. And of course, Microsoft is helping the Mono/Xamarin to a team migrating the Roslyn compiler to the Linux platform. So it's, in that sense, it's cross-platform as well. And because it's open source, anyone can take the compiler and go to any platform they want. On top of that, if you wanted to, let's say, if you needed a feature in your C# language that the C# team itself is not building in, then yeah, you can fork the source from Git, modify the language, and then use that compiler in your applications in your team. I'm not saying that's going to be a good idea, but that's something you can do. And of course, as a result of which, I'm sure lots of people are going to be creating derivatives of C# or mainly domain-specific languages for very specific domains using the C# as a language, but for their domain. So it's called DSLs. So that's another feature that you can do with C#. Or you can also view the source code of C# Roslyn here. They've got an online source code viewer, so you can browse through the code, clicking on links and stuff, just like you do for the .NET Framework open sourced code. Okay, so that's enough about Roslyn. Let's move on to the C# language features. In this version of C#, there are no earth-shattering features such as async await or generics or link. These language features are fairly simple, but I think a lot of them are very useful to help clean up the code and to keep the code succinct, or less code to achieve more, if you will. And we're going to go through the order from here to here, from this column to then this column. I'm not personally thrilled with a lot of these features, so I'll let you know my opinion as we go through these features. So let's switch over to Visual Studio and take a look. So I have a C# class file here. It's called movie, and it's got title, year, genre, image URL as its properties, and then I've overloaded the toString method here to produce the string representation of all of the properties and their values. Now this class is written in the style of C#5, so before C#6. And this class is immutable, meaning once you create an instance of this class, you cannot modify any of its properties. Now immutability is a very important aspect for many things. I use this currently for various business systems or models, if you will, domain models, where immutability is a big factor. Once we have an instance of this class, you want to make sure that first of all it's completely valid, as in all its properties have been set, so you don't have to continuously check to make sure that's the case. And second, nobody can manipulate this model given its original state, if you will. From a multi-threaded, multi-core perspective, immutability is also very important, and in fact you will start to see in the C# language in the coming years, and probably other languages as well, this, I guess, intrinsic built-in support for immutability, such that probably the compiler has intimate knowledge about your classes being immutable or not, and thus can manipulate them different ways at runtime, primarily in a multi-threaded fashion in case you want to improve performance of something. If you're iterating over a loop, if the classes are known to be immutable, the runtime can take special measures to treat them in a safe manner. Because they're immutable, they are safe to be run in a multi-threaded environment. Okay, so that's something that will be coming, I'm sure, in the next few years in all programming languages, because the only way for us to make use of the multi-cores on the desktop machines and of course the server machines is by multi-threading. And if we don't use multi-threaded programming, then we are not making use of all the cores. We're just making use of one core. So this is how you would define a class in C# today to be immutable. So I'm just going to go through some of the terminology here. So this is the public property. It's a get only property, and it uses this backing field to return the value. So each time you ask for the title property, it basically is returning the value of the backing store or the backing field. In this case, this backing field is read only, so it has to be set either inline. In other words, it can either be set, say, like this, or it needs to be set in the constructor as it's doing today over here. So because it's read-only, it can be set it can be initialized in line, or it needs to be set up or initialized in the constructor. After the constructor, there's no way to initialize any read-only fields. So by using a read-only field as the backing field for this property in turn is also read-only. And so this is the entire class now becomes immutable. So now what we're going to do is we're going to use some of the new language features to explain or use this class and some of the language features and put them together so you can get a sense of how these language features can be used in C#6. So the first language feature is auto property initializers. So an auto property is something like this. So this is an auto property. Of course, the name of the property is my property is of type int, and it's a get and a set. Of course, behind the scenes, the compiler is providing not a read-only backing field, but just a backing field that has a very specific name. So it's cryptic in that sense. You can't guess it, or you don't want to guess it. And when you set the property, it's setting the backing field, and when you get the property, it gets the backing field. But you write it like this. This is called an auto property. Auto properties need to have a get and a set. The set can be private. So if you want to have a private set, you can do that. But you do need a get and a set, at least in C#5 and earlier. So the auto property initializers is basically allowing us to set the value of this property or initialize this value of the property without having to use the constructor. So what's happening here is when this value is being set to the property, it's not being set directly to, of course, the property is being set to the backing field. So imagine a backing field like this over here, not read-only, but just a regular without the read-only member for this property as the backing field. This initialization is really setting the backing field. And so when you get the values, returning the backing field's value. When you set the values, setting the backing field's value. So that's the auto property initializers. Now, similar to the auto property initializers, the next feature is the getter only auto properties. So this is new to, again, of course, new to C#6. That's what we're talking about. And that is that you could actually have in C#6 just that. So this is a getter only auto property. Now it may not make sense all by itself, but of course earlier versions you couldn't just have a getter only auto property in C#. So this is a new feature in the sense that in C#6 you can. So combine the getter only with the, let's say, initializer. You actually now have a getter only auto property that has been initialized. So by the time this class gets instantiated, this property has been set to hello. Of course, the same thing happens here is that when you set the value here, you're not setting it to the property directly. It is being set to a backing field. Now the difference between the get only properties versus the get set properties is that when you define a property that is get only in C#6, the backing field is in fact read only. So that's something to be I guess aware of. Now the reason I'm saying this is because this is exactly how, or the reason that they introduced it. They introduced these get only properties, or the ability for us to initialize get only properties, and the fact that the get only properties use a read only backing field is to be able to make immutable classes. So with this new feature, along with the next feature, which is constructor assignment of getter only auto properties, and that's basically saying you can do this in C# now. So you can do that, you can initialize it, but you don't need the backing field anymore. Okay, so you don't need the backing field, and you can also set this property in the constructor. So you're setting the property directly here, even though the property is not a set property, it's just a get. But behind the scenes, of course, the compiler is using the backing field, and it is setting the backing field's value to the value of this parameter here, constructor parameter. So we could essentially rewrite this entire class simply like this. Right, so just you don't need the backing field, and you can define get only properties, and that takes care of all of these properties here. And of course here you don't reference the backing field directly, you reference the property, and the compiler will write the code to reference the assign the backing field. So that's how simple this class now looks with the these last two new features in C#, the getter only auto properties and the constructor assignment to getter only auto properties. I think both of these features are really cool. This is useful. I guess, you know, if you already know the values to certain auto properties, that's great. But what was happening in the past was the getter only, because the getter only auto properties were not supported. I guess the C# language was indirectly promoting mutable classes by forcing you to put a get and a set, and so people were forced to just put a get and a set, and as the result of which classes were by default mutable. And now by adding this getter only auto properties along with the constructor assignment to getter only auto properties feature, they have brought the immutable classes on par with mutable classes. So now you have a choice, and you're not losing, or you don't have to do any extra work like you saw this class before. When we started, it had a bunch of extra code that seemed more than was required for just the get set auto properties. So that's that. The next feature is the string interpolation. This is also another great feature of the C#6 language. What it means is, you, instead of using string.format over here, you can simply do this. So you can put a dollar in the front. Now this feature has gone through multiple gyrations in the C# language, 6 language itself, as in when they first introduced it, the syntax was not what I'm going to show you. It was vastly different and a little more complicated looking. The same goes for the constructor things, constructor here as well. They call this feature, or the combination of all of this, what I just showed you, as primary constructors. And the syntax for that was, when you want to define an immutable class as the only constructor, if you will, that you have, you would take this and you would define it on the class here. And of course the syntax was weird in the middle as well, and you didn't need this entire constructor here. So this was called a primary constructor. Of course that feature has been replaced by these two other features, the getter only auto properties along with the constructor assignment of getter only auto properties. So things might change by the time C#6 is actually released and available. It's planned to be released Visual Studio 2015, and C#6 is planned to be released end of this summer or sometime during the summer. That's 2015. And so things might change by the time you actually see it. So going on to the string interpolation feature. So this placeholder can now be replaced directly with the property. So that's what the string interpolation is allowing us to do, is replace the string placeholders with the values directly in and inside of the string itself. Right. So this whole thing will look like this. So that's the string interpolation feature. Now you can use any member here, as it doesn't have to be a property. It could be a local variable, it could be a parameter to a method, whatever the compiler can discern and understand, you can put within the curly braces. And we look at a little more detail of what else we can do in these curly braces here. But that's the point of the string interpolation. I think this is pretty useful when you're doing a lot of concatenation of strings. This makes it a lot more readable, I think, than doing the string.format features. Of course, in some cases the placeholders do come in handy, because then if you want to repeat the same property multiple places, then you just use the same placeholder index and it'll just reuse that same property again. Here we'd have to repeat, like in this case, title would have to be repeated multiple times. All right, the next feature is expression-bodied members and expression bodies. Okay, I'm going to skip this one, the Null Conditional Operator, for now, because I want to show you something that already applies to the toString method, and then we can move on to the Null Conditional Operator, even though this is a really cool feature. So far, I liked the getter-only auto properties, the constructor assignment to getter-only auto properties, string interpolation. I love this feature. We look at these two now. They're very similar. Expression-bodied members and expression bodies on properties. So members meaning methods, and bodies and properties meaning expression bodies and properties. So let's look at the members first. What this means is we now have the ability to define an expression on a method. So we don't need to define the method with the curly. We can do it kind of inline. Now this is a expression, not a statement block. So in lambdas or in lambdas, you can have a statement block or you can have an expression. An expression doesn't have curlies. It can only be one line. And in the case where it's returning something, it doesn't or should not have a return statement. So we take out this as well. So this is how you can write a simple method. Now the guidance here is, of course, if you have a method that has just one line in it, it's very simple. In fact, even if it's so long, I wouldn't actually use it as an expression-bodied method. But sometimes you just return the one thing, right away. And then you can, instead of defining a method body, you can define an expression for the method body instead of a method body itself. And you do that as if you're defining a lambda variable or a delegate. You're going to say toString goes to such that, or whatever you want to call the arrow, is equal to this thing. So that's an expression-bodied member. I'm going to move this back. I think it's cool if that's what you have. A lot of those methods where they're one-liners, you end up using 3 lines to define the one line. It makes sense. I wouldn't do it for something like this, but the idea is that feature is now supported. The same goes for the expression bodies on properties. If you have a property getter that's extensive, or by I don't mean extensive, one-liner, not an auto property, but like there's a one-liner here, you could simply do this. You could just do that. Of course, there's some code here. So, return something. So instead of returning the something, you can just write the something, and that sort of makes it simpler, especially if this is just a one-liner. The getter of the property is just a one-liner. Now, in methods that return void return or task returning methods, expression-bodied members are supported, and you basically do it the same way. It's not like you have to use it only for returning kinds of functions. So funcs versus actions. You can use it for both. So that's the new feature here for the expression-bodied members and properties. Okay, now let's move on to the next, no, not the next feature, but the one that we skipped over, the Null Conditional Operator. The Null Conditional Operator is pretty cool. So, in fact, before we get to that, let me set up the code here a bit. So let's start with a variable called, I want to use that movies class in some way so we can see it in action. So let's call it movies dictionary. And it's really a new dictionary of type int movie. Now I'm going to initialize this dictionary using the feature that was introduced, I think, in C# 3.5, where you can initialize collections and or property names of classes. So in C# 5, the way you would initialize a dictionary in this fashion would be you would have to do something like that, and then you'd say new movie. In this case, the movie, let's say, takes a title, year, genre. Let's say the genre is action, and an image URL is image URL 1. So that's how you would define a single element. And then if you wanted more elements here, you'd simply do that to add on more. Instead of doing movies dictionary.add, movies dictionary.add, you can initialize these things like this. This is all in C# 5, so it's not something new to C# 6. Okay. All right. Now we're going to just iterate over each of these. This is the key value pair of movies dictionary. And here I want to just write out to the console the kvp dot value, which is the singular movie dot toString. I don't need to call toString, but I'm going to be explicit here. All right, and then just wait here. So let's see this in action first. So that's what it looks like. Let me just add a line between each of these so that it's more readable. Right. So that's how this code gets represented. The toString that we wrote in this class, using the string interpolation, that's how it's being represented here. All right. So what if I wanted to add another constructor to this movie class that took in, let's say, let's say it had a property here that was an enumerable of string, and we called it tags, and it's get only, right? So it's a read only property. Of course, in this case, because this is like a reference type, the property itself is immutable, but not necessarily the collection. Okay, but because it's an enumerable, even enumerables are read only, and so you have to use the combination. Okay, so there's another new property called tags, and here I'll use I'll just use a params of string array, call it tags, and then here I'll assign tags to tags. Okay, so now let's look at the toString representation of this. The idea is that if this collection is null, then you don't want to print this out. So let's say /r/n tags, and over here you want to do something, right? So like that. Now if tags is null, oh, hang on, I want to create a new constructor here. In other words, what I'm trying to do is that there could be instances where the movie instance doesn't have the tags property initialized, because we have that allowed in our design here. So that's title, year, genre, image URL, null. Okay, so there's a possibility that an instance of a movie can be created without the tags, because we're allowing for it here. Let's go into our program CS and add tags here. So let's say tag 1, tag 2, tag 3. Okay, so we have this one class has 3 tags called tag 1, tag 2, and tag 3. The others don't. So if I were to do a toString here now, let me go back and fix that. Okay, I already did that. So I've added the tags property here. What's going to happen is that, first of all, we don't see the value. We're just seeing an array here. So we want to see the value. So we need, let's say, a comma delimited list of tags here. So one use that you can use the null conditional operator for, I'm going to do it outside here so you can see. Let's call this tags, and this tags is as a comma delimited set of tags. I want to produce the string representation of that. I could do string.join, and I'm going to use the comma separation feature. Now here you need an array, and we have, of course, a tags dot toArray here, and it'll work just fine, and this will give us a comma delimited string. I'll put this tag in here. Okay, so watch what happens now. Now what we have is we get an exception, because only for the first item did the tags actually contain something. In the next one, this tags is null, right? So we would have to have some sort of a null, a conditional check for null, and that's where the null conditional operator comes in. We could do something like this. We can say tags ? dot, and what that's saying is, if tags is not null, then call the toArray method on tags. Okay, so if tags is not null, then call the toArray method on tags. If it's null, don't do it, right? Of course, that'll still equate to a null as far as the string.join method is concerned. So we need an alternative, but that's nothing to do with the null conditional operator. If you have, maybe I should explain this in a simpler manner. Let's say we have a class here. Let's say it's an instance. It's an I disposable. Let's say disp. For now, I'm just going to do a null. Then I have a try finally here, and in the finally, I want to dispose of the dispose, right? This disposable. I want to do that. But what if disposable is null? What if this disp instance has never been initialized, or something happens by the time it comes in here, it never got initialized? But then you have a problem here. This is null, so you can't call dispose on it. And this is where the null conditional operator comes in handy. You just do that. So only call dispose if disp, the variable here, is not null. That's, I guess, a better way to explain the null conditional operator. Now, you can change these. So you can have, let's say this. If this class is not null, it has a property that returns to you another collection, another class that has a property, and so on. You can change them. So you could do question mark dot and chain it. I don't recommend that, but if the need arises, that's a possibility. I love this feature here because actually you have, typically you would have to do something like this. If disp is not null, then call disp.toDispose. So this is the representation where you don't need to do that anymore. You can just do disp question mark dot. Okay, so now let's go back to the string interpolation part, the toString aspect there. So if tags is null, not null, then call the toArray. And in earlier versions of C#, we've had a null coalescing operator, which is the double question mark. So here you could say, okay, well, if this entire thing is null, then do something else, right? So that's giving us that opportunity. So we can combine the null conditional operator along with the null coalescing operator. So here we could say enumerable dot empty. In other words, just provide an empty array. So if this instance is null, then we need to provide an empty array, and that's what this is going to do, right? And then you take that right in here. So what we'll see here is either a common or definite list of tags, or we won't see an exception. We just see nothing. And so you can see that in the first instance's case, we have a comma separated list of tags, and then the other case is nothing but no errors either. Right? So that's the use of the null conditional operator. Now, while we are at it, let me also talk about the nameof operator. This is a new feature in C# 6, of course, and it's called the nameof operator. And the way it works is like this. So within a method, either when you get certain parameters, for example, here, or if you have variables or properties, the nameof operator can be used instead of the actual property. I'll give you an example of what that means. So let's say over here, I can say nameof title. Now, of course, the result of that is a string, so it'll have the string title in there. But the reason you would want to do this is in case you change this title to, let's say instead of title, you call it description, right? So if you call this description and you replace this rename title to description, it also renamed it here. See, sorry, my mistake. This is not what I want to do. This is not the right example, because this is the value part. It needs to be here. So instead of putting this over here, I could say nameof in here title, right? But that'll again have to be in parentheses, sorry, in curlies. So it'll be this nameof title. So in other words, the word title is now I'm using name of titles, and when I change it to description, it'll actually show up as description and not title, right? So if I now change this property to description and I replace it, you'll see that it changed it everywhere. So even here, even when I'm using it as a string representation, it changes it, so I don't have to keep things in sync. Okay, so that's one use case for the nameof. So anywhere you use a string representation for something that is known to you to be a property or the name of a parameter or a name of a variable, you use the nameof operator so that they can be in sync and the compiler can check you. So if this were not actually called title, right, this way the compiler can check you. If you make a change, you call this description, you would like to say description, not title description, and that's where the nameof operator comes in handy. There are certain exceptions like argument exception, where you pass in the name of the parameter or argument that is null. Well, if you change the name of the parameter, then you have to go change the message as well, and that's again where the nameof operator comes in handy. The compiler will check to make sure that that it knows that variable. To make that a little clearer, let's play with some of the features here. So let's call this m is equal to movies dictionary dot first. I guess I don't have the link. Dot link. Okay. Dot first. Okay. Now what is if I did this? So I did a name of m. What do you suppose is going to be the result? So I'm going to give you a couple of seconds to figure that out. All right. Now let's run this to see what it is. So of course, because it's the name of the member, it's going to say m, not the value, but this you're asking for the name of the variable, and that's why you're seeing m here. Now of course, if I changed this to mm, and let's say I was just writing this out as a string, the compiler wouldn't be able to tell me that, hey, you missed out the mm over here, but now it's actually complaining, so it does not know what m is. Right, so that's the sort of the beauty of that. And of course, then you can get the rename option here to then rename m to mm everywhere, and it also replaces it in there. Right, that's one. So let's try another one. Let's do this name of program being this class here. What do you think is going to be output to the console? Let's check that out. So of course, the name of the class is program, right? And that's what the nameof operator does. It gives you the string representation of that member or variable or local variable or parameter or property, whatever. If I said name of program.main, what's going to happen? It's going to also give you main, right? Because the name of program.main is main. It's the string representation of what you're seeing there. Again, the advantage is that when you change something, if I change this method name to, I can't do that here, but if I change it here, I'll get the code, the ID to help me with the renaming, and the compiler will check to make sure that I've not misspelled it or misnamed it or forgotten to rename it, that sort of thing. That's where the nameof comes really handy with the strings, with in some cases error messages and stuff that you're logging, etc. All those kinds of areas. It's also decently cool feature, I guess. Okay, so moving on to the next feature. New feature. So we finished the expression-bodied members, expression-bodied properties, and we jumped to the nameof. I'm going to go back up here to the index initializers. So in our dictionary initializers here, I'm using the syntax of the curly brace and then the key, comma, value. Behind the scenes, the compiler, of course, is calling the add method, and it's saying movies dictionary dot add. Let me show you that syntax. Movies dictionary dot add, and then it takes the key and the instance of movies. That's what it's doing here. Behind the scenes, it's calling this add method, providing these two parameters. Because this is just compiler syntactic sugar for us to keep it simple for us to add items to, in this case, a dictionary. So in C#6, they added this feature called index initializers, and what it is essentially like this. So that's the key, and it's equal to this value, and you don't need the curly. right? So I'm just going to change all of these. So slightly simpler syntax. Maybe some people might find it more intuitive. I got used to the earlier version, so it doesn't make a lot of difference in regards to readability, but maybe over time it starts to make more sense that you're really saying this key is equal to this value in this case. And that, I guess, makes it look a little cleaner. I don't know. The same can be used for, I have this toString JSON method that I've already written. And again, the same technique is being used here to initialize this JSON object with a bunch of name and values. And so you can do the same thing. You can just say that is equal to this. So it makes it, I guess, a little more. This in JSON, of course, it makes it look a lot more readable. That's how you kind of see JSON to be. And in addition to this here, what you could also do is that you can say name of, title. Of course, there's no such thing as title. It's actually movie.value.title. So name of that. Right. So if we change the movie's title property to be called description, and we use the rename feature after that, it would rename it everywhere, including here. So you won't be ever out of sync. And that's one nice thing of the name of. And we're using it within the index initializers here as well. So this could be, you could do the same thing there. I'll just undo this. Okay, so that takes care of the introduction to the feature about the index initializers. So this applies anywhere you have some sort of an index property or indexing of an array or some collection. The syntax makes it easier to do that initialization. The next feature is exception filters, static, using static, and extension add. So I'm not a big fan of the exception filters feature, nor the using static. The using static is a little easier to explain, so let me show you that first. The using static is, you got all these static classes that are being used, and let's say in some classes you've got there's just a clutter of having to reference the static class before you can reference the method, and you feel that to be clutter. You have the option now with C#6 to define in the using, you say using static, and you can say system.console. Okay. Now this is looking a bit dimmed out here because it's not being used. And in fact, if you look at the help, it's saying remove unnecessary using. So that's a feature of the Visual Studio 2015 IDE, where you can remove unused usings or sort them or whatever. And on top of that, you can go either in this document only the entire project or the entire solution. So I think that's pretty cool. So you do it one place and it kind of does it across the entire solution. But in this case, we are not using the feature, and so it's saying it's kind of dimmed out here. And similarly here, it's saying in some ways you don't need to use the console class name prefix here. So if you remove this here, and that's probably the help that you're seeing over here, it says simplify member access, and it shows you the sort of expected result over here. So let's do that, and it's gone. Well, I guess it didn't do it everywhere. We should have probably picked document. So take it out from anywhere possible in this document. Well, maybe it's not. So that's the idea with the static using feature. And maybe it makes sense if you're using it a lot in a certain class and the class name is sort of cluttering up the rest of the code and making it unreadable. But I don't think I would like to see this happening every time we use, let's say, console or writeline or math class or some string function. Just because we can, and that's one of the reasons I don't quite like it. And as you can see here, this is no longer dimmed out. This one is dimmed out still, so this is unused. I'm just going to take that out. So static using. The next feature we can talk about is the exception filters feature. Exception filters. So what the feature is really saying is, if you have, let's say, a try catch block here, and yeah, of course it's not going to be exception, some other specialized exception here. I'm just going to leave it at exception. You can have here now you can say when, let's say, I don't know, e dot source, equals something. This expression has to return a bool. So this catch block will be, I guess, it'll catch this exception here only when, of course, the type is the same exception type and this condition is met. That's like an additional filter on this. So you could have multiple catch blocks for the same exception, but for different filter criteria. And for that filter criteria, if the criteria is met, and of course the exception type is the same exception type, it then comes into the catch block. Now, some examples of this that people have shown are things like, let's do a log here. So there's a method that says log message, and it takes in the E, and let's implement the message here. It says is by force a bool returning method. That's, for me, that's my first problem. I don't like methods that return a bool to indicate true false of something was successful or not. So why would I do that? Why would I have such a method here? And secondly, what if there's an exception writing to the log file? What if there's an exception over here? What's supposed to happen to this exception? Now you got another problem, right? So it sort of makes sense that you can do something like this, but I'm not sure that's the best way to handle exceptions. I would say if you have complicated logic, for example, if you didn't have this feature, then you're probably doing it in here. Well, I say, call another method here, let that method determine what needs to be done, rather than using the filter feature, and then you have a clutter of filters for the same exception in this try catch. Anyway, that's my opinion. I'm not a big fan of this idea. Maybe I'm not able to wrap my head around when I would use it, but I'm very, very particular about how I deal with exceptions, and so maybe it just doesn't fit with my my thinking. So that's the exceptions filters feature, and maybe it stays, maybe it goes, I don't know. As I said, none of these features are carved in stone yet. The await in catch and finally is a feature that they, I guess, couldn't wrap their heads around in C#5 or didn't have the time. Now they've finally finished that off and they've implemented that. What it really says is we can use the await keyword inside of a catch or a finally block. And again, the only use case I sort of see for that feature, I think it's a great feature that they've completed the async await feature and has become a true first-class citizen of the C# language. But what are you going to do in an exception that is IO bound async, right? Probably log to a file, and that may be handy, but that's sort of the use of that. So now you can log stuff to a file in a catch block asynchronously, and that's cool. Not a major feature, but they've completed out the async await feature from C#5 in this case. The final one is the extension add, and the extension add feature is basically there. You could have in your like a dictionary, you can have an extension method that does an add, and so here, as I said, it's behind the scenes using an add method. But what if you had your own extension method? Well, this feature would not use your add extension method. It would use the built-in extension add method of the type of class that you're working with. Now the language supports calling out to any extension methods that are add methods as well. So if you have your own way of initializing the collections, then that method can also be used. And that's I guess that's a feature also that's pretty cool. I don't use extension methods, but that's my own choice. But maybe some people do and they find that useful. Because obviously somebody made a demand for these features, that's why they exist. So it's not fair to say that I don't personally like it, you may like it, because you probably were saying, yeah, I got this feature. Anyway, so that brings us to the conclusion of the new C# language features as it stands today on the 4th of April 2015. Sorry, not 4th, I meant 12th of April 2015. So I'll see you guys next time.